Modern industrial automated machinery is powered mostly by motors. The torque generated by a motor in operation provides driving force for conveyor belts, gears, chains, and other mechanical components. So, a motor naturally becomes such an integral part that is key to the driving system. When it comes to the protection of core power part, you can't pay too much attention to it. Thermal overload relays are used to provide overload protection, open phase protection, and protection against unbalanced current for motors. And they can also avoid heating in electrical equipment. The thermal overload relay works by thermal effect of electric current to push the action mechanism to make or break contacts for protection of electrical appliances. A thermal overload relay consists of a thermal element, action mechanism, bimetallic sheets, contacts, a reset button, etc. To use the relay, you need to connect the heating element in series with the main circuit of the motor, and let the normally closed contacts in tandem connection with the control circuit of the motor. When the motor is running normally, the heat produced by the thermal element will bend bimetallic sheets, but it's not adequate to trigger the contacts of the relay. Once the motor is overloaded, the bending degree of the bimetallic sheets increases to push the guide plate to separate the normally closed contacts. Now that the control circuit of the motor has been cut off, the motor is put under protection against electrical faults. There is a buckle on the relay to be inserted into the hole on the contactor. And take a screwdriver to tie them up. To further make sure the two devices are securely connected, we will use a multimeter to test them. Thermal overload relays generally works in tandem with contactors to control the operation of motors. The wiring is not complicated. What you need to do is connect the input terminals of the relay to the output terminals of the contactor. The three-phase power supply is connected to the input of the contactor to power the system on, and the output of the relay is wired to the motor. You can select between normally open or normally closed contacts on the relay to control the coil of the contactor. Here we'll use the normally closed contacts. The hot line is wired to one of the normally closed contacts, and the other one is wired to the coil of the contactor. And a blue wire goes from the contactor to the power supply so that a circuit is formed. Let's see how it works. Switch on the power, and since we choose normally closed contacts, the whole circuit is closed so that the motor starts running as soon as it's energized. The red button is to stop the relay. Long pressing on it will break the circuit and the motor is de-energized. You can see the motor is slowing down and finally stops. However, once the button is released, the circuit will be closed again and the motor will be energized and be running again. Therefore, it's a momentary button, not a latching button.